So here we go. Okay, so today's talk is on ChickyNoid, which is the server authoritative pew 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 character controller for Roblox. So I'll just start with a quick introduction. Who am I? Well, my name is Peter. I get called Peter occasionally by people who know my name is not actually MrChickenRocket. That name was given to me by my kids because they wanted me to come play on this new game that they have called Roblox, and that happened about 3 or 4 years ago. So MrChickenRocket is just my Roblox handle. I was previously a engine tech director for King, so the people who make Candy Crush, and I was there for 5 years over in Sweden. And before that, I was the principal engineer for Half Brick, the team that made Fruit Ninja. And for about 10 years before that, I was in and out of various indie game studios and whatnot, working in the mod scene, working on things like Quake 3 Arena mods and stuff like that. So I've been a game dev now for a little over 20 years, and I've always just wanted to make games, so before commercial engines were even available, you had to make your engine before you could make your game. You had to write your own tech. So becoming an engineer doing engine stuff was just accidental for me. It's just how my career ended up. But it was always about making games. And so now that I'm on the Roblox platform, I can make games with very small teams, and it's very, very cool. So my specialties are mobile rendering and optimization, gameplay systems, and obviously because of today's talk, I know a thing or two about networking and network code, so I'm going to hopefully be able to share some of that. So what is ChickyNoid? ChickyNoid is a server authoritative character system for Roblox, aka almost most of a game engine from scratch in Lua. I've got links to the Git repo and the Roblox game. The link is up in the game general channel, so we can jump into that and have a look at that in a little bit. And the other thing I wanted to point out is the reason I've been able to get so much done on ChickyNoid lately is I'm being patroned by EasyGG, also known as the Bed Wars people. So fantastic that they've done this, and they've been able to make this whole situation open source, which should be hugely appreciated. So the main concepts today, we're going to cover client-owned players, which is what's already in Roblox, and talk about the pros and cons of that a little bit, just to lay some groundwork. We're going to cover the server-owned players, which is what ChickyNoid is doing, which is where a character is completely owned by the server, and therefore you are at a much lower security risk. We'll talk a little bit about client prediction and why, and then all of the smoke and mirrors that you do to make prediction feel good, which is the hard bit of this whole thing. And then we're going to talk a little bit about security checks that you can add on top of things, because you still have to trust some things from the client, but because of the way the data model is laid out, you've got some very easy ways to run analysis on it and make sure it's all legit. That's novel. I don't think that's covered anywhere else on the internet yet, even though most of these general concepts have been implemented in a bunch of other games like Overwatch and stuff. Oh, well, it's my little girl. She's heading off for her afternoon nap. And then we're going to cover firing bullets. So talk a little bit about doing server-sided bullet checks. And if we get time, I would like to cover some bonus topics, which is writing a player controller from scratch. So talk a little bit about the controller in ChickyNoid, like how you actually basically can make a first-person shooter controller or a character model controller without using the physics engine, like doing every step of it yourself. Because there's actually not that much source code once you lay it all out. Talk a bit about the replication and compression stuff that we're doing inside of ChickyNoid. These are not new techniques, but there's some interesting bits and pieces in there. Talk a little bit about the collision detection system that we had to add to ChickyNoid, just because Roblox didn't provide one, and it kind of spiraled out of control. We basically ended up re-implementing all of Roblox's collision detection again from scratch. the mod system, and a little bit about the terrain collision and marching cubes, because I had to do some novel stuff there too that might be interesting to people. And all right, so getting started. That's it for the slides. I'm not gonna stick slides in everybody's face for the rest of the day. What we'll do first is we'll jump into, hang on 1 second, please. Got various accounts. Would you believe it? I'm actually eating a Roblox upgrade right now. Hopefully nothing broke. Okay, so I linked this project in the general chat, so I can see some people already running around. There's me. There's my little dude. You can see I've got. You can see this is not the standard controller. This is a. Well, someone's spraying me down. You can see this has got some things in it that are not standard to Roblox, like Quake-style jump pads. The anti-lag debug system is on, so you can see that that's all working. There's an interesting net graph that I want to talk about a little bit, and all of the custom collision detection that's going on so that this all works. So, like, this is really boring because it just looks like we have a normal character walking around inside of Roblox. But the truth is that this is all 100% custom code. There's no physics running, like the Roblox physics sim isn't running, and the Roblox collision detection isn't running. This is except for the bullets, they use that. But yeah, so this is pretty much all from scratch. I'm going to jump out of this and go to MS Paint. All right, so just pulling up my notes. Okay. So in Roblox at the moment, we all know humanoid, and we all love and hate this thing. And so the idea is on your client. 1 second. Wow, this is lagging hard while streaming. Can you just give me a second? I'm just going to restart Photoshop. Just make sure this is all fine. It's much better. So on the client, we have our little dude. And then we have our server. And this is going to seem really basic, but every frame on the client is the way Roblox moves. It runs the physics simulation for the little guy, so he can move any way he likes. The information about that goes to the server and then goes out to everybody else. Okay, so that's is really hard to talk about and avoid, right? Okay, so every single frame, whatever the client does, whatever physics that they run, whatever movement that they do, is basically, none of that is challenged by the server. It's basically taking the direct position, the vel, directly from the client, accepting it on the server, and then it's redistributing that out at a 20 hertz replication out to everybody else. And so the clients wait until they've gotten 2 steps of that on and then we're constantly interpolating. So once we've gotten enough of them, it can interpolate from a previous thing. So rendering might be here, like in terms of real time between the time that a snapshot arrives on Roblox. So this is where we're currently looking. And then back exactly 50 milliseconds is where it's trying to interpolate between the two things. Is there a chat for people to like type in or ask questions while I'm working on this? Is that something that we have set up?
Yeah, if people want to ask questions in the code channel, I'll check now and pass any along that come up. Awesome.
Okay, thanks. That would be good. Yeah, so this is basically the Roblox model at the moment, right? Hopefully that's super clear for everyone with my dodgy sketch, but essentially on your client, and if your client stops sending something, you just freeze for everybody else. So there's a super old trick that was shown to me by my own children where you can just grab the taskbar and freeze the game, and you will freeze in the air for everybody else because your client has stopped sending commands, stop sending positional updates of your character to the server, and then so the server has nothing new to send anybody else, and so your character just freezes in place. But you can also do all of the other anything he wants with your character, which is you can fly, you can teleport through walls, you can make your velocity super high and then run into somebody else and fling them out of the map. It's generally very, very difficult to tell the difference between what is legit data coming from a client on the server and what's just lag. So people have written scripts to try and make sure that the players don't go over certain speeds and they don't fly around, or they're not flinging other players and stuff like that. But generally, it's been an uphill battle. So what ChickyNoid does is the same thing that Overwatch and Counter-Strike and CS:GO and all of those do. 1 second, please. Which is it moves the model around a little bit. And essentially what it says is on the server, so we have the server, and now the server owns all of the players for everybody, and the client and replicates this out as per usual. Server replicates it to everybody else, but the client only now sends over button presses. So it's like a little Atari joystick. So if you're moving left, you're moving right, you're pressing jump, that goes to the server now. So it's just what we call a command. That goes to the server, and then the server runs all of the physics on the players, moves them around, and then that gets replicated out to everybody else at 20 hertz. Okay, so this is a super duper old technique. John Carmack invented this for Quake World back in 1996, 1997. It was designed as a solution for modem gameplay for Quake, because previously all of the network models had been lockstep, where basically the whole world could only process forwards if everybody agreed that the next frame should happen. And obviously that's got some problems when latency gets involved. So this is where we're at with things now. So obviously, if you're looking at this, you think this has got some problems. This isn't going to work, right? Because the time it takes for this command to get to the server is like half your ping. Use a small brush. 1 second. So that time is ping over 2. And then the time it takes for this to happen is also ping over 2. Plus your 50 milliseconds here, at least. Plus, what if this is running at like 60 hertz and you're running at 60 hertz? The maximum shutter of that is like another 33 milliseconds in the worst case scenario. So this is so your effective ping between the time when on the frame that you press the button and the time before when it's come all the way back around to you seeing what you're doing is like your total ping time plus 50 milliseconds plus another 33 milliseconds. So that's gonna feel pretty laggy. There are games now that ship with that as their entire network model. So things like Gang Beasts and Party Animals, which are these super physics heavy games, they're just running on this model with no other smoke and mirrors or any other real way of smoothing it out. I've built an example game in Roblox where we just do this, where the client moves, sends input to the server updates the physics and just replicates it out. It feels sluggish, but it's not great. It's certainly not going to feel as good as a client predicted humanoid, which is what the end result that we all want is. So after we've done this, we have to basically start doing smoke and mirrors on top of this to make this feel better. So essentially what you want is to have... Wait, just before I go any further. So everyone's following exactly what's going on, right? In like this basic model of client makes an input, the input gets sent to the server moves the player around, the player gets replicated to everybody else. So we're all following on that? Good. Okay, so that's the core concept. This isn't what most games ship with, but this is the starting mental model you need before the rest of it to make sense. Okay, so the next step is make this feel good. So essentially, to make this feel good, what you're going to need is the same thing, except on the client, you're going to want to also have a copy of your player that responds immediately to the joystick inputs and responds in a pretend way, because the server is still the authoritative view of everything. So ignore what the server says that your position is based on this replication. Have your own version of the client, and every time you make a command on the client, move this little guy around on his own. And so what's going to happen is if everything is perfect and the server always 100% agrees with everything you ever do, then no problem, right? Because if everything's deterministic or near enough to deterministic, then your little dude that you're predicting here in red and the actual server version that's delayed but coming around, but the server view of you who's going to be back in time. So what I'll do is I'll just move this around. So you understand.
There was a question.
Time kind of moves this way.
There was a
question.
Sorry,
there's a question?
Yeah, I'll just read it out. For fully physics-driven games like Gang Beasts, why don't they do client prediction? They have a reason, right? I'm assuming it would be too many physics discrepancies, or is that not an issue since physics can be completely deterministic?
The reason that they don't do... The reason games like Gang Beasts don't do client prediction is because, for example, this little dude here that we're moving around is ahead of where the server view is. So we've responded to this move long before the server is able to send us confirmation of what's actually happened. So excuse me. So much later, SpongeBob style, we actually get confirmation back on it. So this was our input number 20, and then like 200 milliseconds later, we actually see input number 20 on the client, right? Same thing goes for Gang Beasts. So if you make an input in Gang Beasts to move your guy, the server can only send you back the results of that input sometime later. Now, if you've got a whole bunch of players in a melee situation where all of their physics are overlapping and stuff like that, essentially you've got multiple different truths. You have your truth that you have on your client. You have player B's truth on their client, and everybody's ahead of where the actual server simulation is. So you're essentially in a situation where the server authoritative view is always wrong for everybody in all situations. You can't know what other players are going to, you can't predict forward what other players are going to do in a really reliable way, so they don't even bother. Like, you could try and guess what people are going to do in the meantime before you actually, like, I don't think I've been very clear here. Maybe an easier way to put it is, you're always ahead of the server here, right? Like, on your version of the client, like the server last time they confirmed you at this time, the server's still way behind you. So you're in the future as far as the server's concerned right now at all times. So you need to know what player B is going to do in that elapsed amount of time between when the server last told you what player B was going to do and then now. And you can only guess. You can hope that they're going to do the same thing, but most of the time you don't know. So they don't bother with. So these games have gotten around that problem by not bothering. You could extrapolate their inputs, you could extrapolate their inertia and stuff like that, but you were almost always going to be wrong. It's almost impossible to extrapolate somebody walking around a corner. And it gets worse and worse as ping gets higher. So they've just offloaded the problem and said, all right, the only authority view of everything is on the server, and we're just going to have client to command to server to everybody else, and you just eat the lag with very, very little smoke and mirrors to try and cover that up. It's fine because the characters feel slow and sluggish anyway. All right, back on topic. I'm not sure what I've done wrong. Should have been on a layer. That's what's bothering me. I'm going to move to a layer just so that I know what I'm doing. Okay. So we were talking about client prediction and the smoke and mirrors, and this is the hard bit of the model. So essentially, once we've got our own little copy on the player on the client, we can update it by all of the commands that we know of as they come in. So the client generates a command. So with every frame we have an input, and we play it locally. We move our little guy forwards. We send the same command to the server. It moves its little dude around, and if they never mismatch, then we're all good. But they do mismatch, and so that's where we start getting into the hard bit of the whole algorithm. So this is where we start getting into what's called rollback and mispredict, or yeah, we'll just go with those two terms. It's called a bunch of different things in the industry depending on the type of game you are, but yeah, like client prediction, rollback, or misprediction is basically the three terms that I've heard used for it. So drawing it from scratch, we have time on the client, time on the server. There have been other talks that cover this model really, really well, by the way. Like the Overwatch team gives a fantastic talk on it. They do some stuff that I don't terribly agree with, for like when things get wacky, but in general, it's the same kind of thing. So this is time marching forwards. And so just imagine that these are discrete frames, like something notched like this, but I'm not going to draw all the notches in. Just assume that roughly every 2 centimeters of this is a new frame, just for the sake of drawing. Okay, so we generate a command on the client. Takes a while for that to reach the server. The server confirms it, and we get it back around here. So that's essentially what's happening at the moment. So this little block represents a command. The command gets turned into whether this command is good or the results of this command, and then it comes back to here as a result. So we'll draw that as a result. So this is essentially the model that we have. So every frame we generate a new command, it goes down to the server, comes back, ding, 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 ding. And this also gets replicated out. The results of this frame get replicated out to everybody else as well. This is the same sort of thing we were just looking at before, but I've just moved it into 2 different timelines so that we can see. This should definitely be a blue version now because the server has confirmed it. And this is the blue one because this is the server result. This goes out to everybody else as well.
Brooke asks in the chat, I don't want to steer too far off here, but what don't you agree with in the Overwatch model? I've seen their talk a number of times, and I'm curious what you would do differently.
Okay, I'll cover that later on in the talk today when I get into security. But essentially, Overwatch does this thing where they dilate time that is completely unnecessary. So that's what I disagree with them on. You don't need to dilate time to make this work. I think that they had a good idea and they went with it, but it's actually an exploitable vector on their side. And I'm aware of several Overwatch cheats that are basically using that to do bad stuff. Okay, so the model is we generate a command goes to the server, generates a new state for the player, goes up here. Yep, everything's good. So this is the server authority view of the state, and off it goes. That's going out to everybody else as well. Then the next frame, it happens again, yada yada. Okay. Now, what happens is we get one of these back on the server, and we're building our own model of things here. So we have a new command comes in, we build our own model of things. Command comes in, we build our own model. Command comes in, builds our own model. Server comes in, and our model and its model, they disagree with each other. This is where we have a rollback. So every time the problem is this command that's come back from the server matches up all the way back here. So we've made a whole bunch of new states, or we've basically been walking around without knowing whether or not the server agrees with anything that we've done in the meantime. So hopefully you should understand that from just a basic sort of network game feel. You're sending inputs to the server. It takes a little while for the results of that to come back from the server. And you don't know if the server agrees with it or not because there's network latency involved. It has to go all the way down and all the way back. So what happens if these two agree or disagree? Well, it doesn't actually matter if they agree or disagree, because what you can do is every time you get one of these new commands back, is you can do this thing called a resimulation. Now, resimulation is the heart of all of these games' network models. Some of them do a resimulation every single time a server event comes down. For example, Unreal definitely does. Quake 3 by default definitely does. And a bunch of other engines do as well. So what a resimulation is, it's saying, okay, so for this command back here, which we'll call command X, we've got result X back. Now, we know that we've done all of these other inputs since then. So what we're going to do is we're going to reset to, instead of going for this state, we're going to set our state back to the server state, plus we're going to step it forwards with all of these other inputs every single time we get a server back down. new server state back down. So we have 1, 2, 3, 4, 5 commands here. So we're 5 frames behind the server. Normally it's about 15 frames, but whatever. For our case, it's like there's 5 commands in here. So every single time a server state comes in, we go and apply all of the changes that have happened since then back onto the player. So to show you what that looks like in code, we have a list of commands that the server hasn't confirmed yet. So this is on the client if we're doing resimulation inside of ChickyNoid. So we're just figuring out some times. We'll just forget this line here for the time being, and let's make sure that I'm zoomed in well enough to be able to see things. So for every command that we have left in remaining commands, we run the simulation and we process the command again. So a command is an input. And that's it. That gets you back to where you are. So essentially, oh, sorry, I missed a step here. So when a new state comes down from the server, every single time a new state comes down in the naive version of things, we grab the new state off the server and we apply it to our simulation, which basically resets our base simulation to match the server because a new version of things have come down, which basically puts us back in the past. And then so we replay all of the frames between the past and now to get us back to where we are, which is we run through the loop and we process all of the commands. And that's it. That's really the whole magic behind things, because this lets your client be in the future as far as the server is concerned. And if the server disagrees and moves you somewhere else, well, you just apply all of the commands since that point back onto you. And so none of those commands were wasted, but how they get interpreted changes. So if suddenly the server has moved you to a different point where there's suddenly a wall in front of you, all of those commands that you're previously using to run in a straight line are now just plowing you into a wall. And so you feel this in these games as a kind of a tug or as a mispredict.
Are there natural examples in first-person shooters where you'd have commands that only can be executed in certain regions, like opening a door or pressing a button or something? What do you do with commands like that in some sense can't be moved?
Okay, so there's a couple of different ways of handling the model here. The first thing I should have covered is what's actually in a command. Let me just, sorry. All right, so all that's in a command per frame is your movement desired direction. So like your XYZ unit vector for saying I want to move forwards, left or right relative to your camera. The current delta time for the frame that you're on, which I'll talk a lot about in the security section. The current guest time on the server, which is used for anti-lag bullet checks, and whether you're firing, and your aim vectors, like for where your mouse is. So there's no actual, all of these have security implications for allowing these through, but generally the server is trusting all of this stuff within reason. So instead of trusting your position and velocity, it's only trusting your inputs, and it's using those inputs to move you around on the server. In regards to your question about how commands are interpreted, there's a thing inside of this called simulation. So I'll pop that open now. So what happens in ChickyNoid is every time you get a command, there is an object called simulation, which contains your current state, which has your position, velocity, and some timers on it for various things related to the character physics. But it's mostly about position and velocity. And every single time a new command comes in, a process command gets called, and then it steps the physics for this character forwards one lot of, or steps the whole world forwards one lot of simulation based upon that command. So if you move, it'll move you forwards by dt times your velocity. If you press jump, it'll start a jump. If you press shoot, it'll check to see if you have ammo and if you can shoot your bullet. And essentially, this simulation code is the same code that's run on both server and client, exactly the same code. I use a module script to do that in this case, so that it's exactly the same. No chance of there being a mismatch in the code that runs and stays deterministic. So to answer your question directly about what happens to commands that don't make sense anymore because the server has said you're in a different position, as each command is processed discretely on the client during the resimulation phase, any distance checks, like I pressed the button and there's no longer a button there because you've been moved somewhere else, they'll just whiff. They don't make any sense anymore. And so they won't run inside of the client side. But the thing is, things like buttons and stuff like that, they get handled on the server. So unless you need specifically to predict the button press on the client, you just let the server handle things like button presses. And that's really one of the beautiful parts of this whole model, is that the server-owned view of things, like the server-owned client that you have, becomes the source of truth for things. If you grab the server-owned character for any player and you set their velocity to 1,000 and shoot them up in the air, that's the truth. It doesn't matter what the client says that they did or what the client's inputs are. That character's going to the moon, and their client side will mispredict for a split second and say, well, where I thought I was for the last 10 frames is wrong, and it will interpolate and blend to where it should be as it catches up and replays those frames. Yeah, great.
What's actually in the state record that the server sends back to the client?
What's in the state record? Two things. There is this. I actually should just write it down the end here if I have a look. Sorry, this has all been refactored recently, so I'm just scrolling through to find it. Yeah, write state. Yeah, we grab. This is just a compressions tool, but it's really just grabbing the state and the constants. So the contents of these two records, constants. Sorry. So we're grabbing this record here and this record here. So this constants are basically another state, but are designed not to change very often. So this is all things like your max speed, airspeed, acceleration curves and stuff like that for your constants. And this is your per frame, the state of where you were after the last command has been executed. And the other thing that's inside of what comes down from the server when it's sending down a record is the frame number of the last command that it confirmed. So remember, you're running ahead of the server. And so the server is basically telling you, okay, so you might currently be on command 200 locally, but I've only confirmed up to command 150. So you know out of all the commands you've generated, from command 150 to 200 still hasn't been confirmed by the server. So that's essentially what we were looking at here with this thing. So if we go right through this function frame by frame, this is the server basically sending down, saying, here's the last version of you that I've confirmed. So state delta is just a compression thing, so it's really just a copy of the whole state. The last confirmed command index and the time that it currently is on the server in terms of like the world on the server is constantly ticking forwards, and everything has time stamped. So that's that time there that's come down in the packet. So we quickly build a list of the remaining commands. So essentially, we have a list of all the commands we've ever done. We know what the last command from the server was. So if our command index here is newer than the last confirmed one, we stick it in the remaining commands table. And if we want to resimulate, which we do, but there's some optimizations to see if you can skip resimulation by comparing states and stuff like that. We're not going to cover that today, but essentially you don't have to resimulate every single time you get a state down from the server, because you can tell if the server and you agreed upon where things were. If you do, you can skip it. But if you are resimulating, it's that loop that I showed you before, which is essentially you jump back to where the server said you were. So you reset the state on your character to exactly where the server said it was, and then you fast forward quickly, all in a single frame, to all of those frames that needed to be processed. So that's really, none of that really requires anything magical. Like if we could fast forward the Roblox physics simulation, or fast forward a Roblox humanoid and make it jump forwards 20 frames inside of a single frame by calling update on it 20 times, we could replace all of this with humanoids. Or we could replace all of this with a full physics simulation of a car, because we just have to jump the whole world's physics simulation back to where the server said it was, and then process off all of the unconfirmed frames since that point. I made a proposal to Roblox basically along these exact lines. So hopefully they'll heed that at some point, and maybe we'll get something like that in the future for being able to do not just fully secured player movement, but fully secured physics in general.
So to be clear, the only thing that the client is predicting and then resimulating is the state of their own character model.
That's right? Correct at this point, yes.
So if there are like, if you like shoot an object and it needs to start flying around the map, the server, like you have to wait for the server to move it, and that just gets replicated to you?
Yes, at the moment that's the case. You can, I've gotten other versions of this kind of code which do a full world simulation and rewind the world, including all of the enemies and baddies and bullets, and also let those fast forward. So you're basically doing a full prediction of the entire world state, including all of the gameplay code. But that's completely overkill. And it basically requires you to write all of the gameplay code in a very awkward sort of way. Because if you do it that way, all of the gameplay code has to basically be aware of the fact that the same code is being run on the server and the client code is either a normal step forwards or part of a resimulation. And things like special effects for like bullet firing and projectiles and explosions gets kind of gross and weird. So I just avoided that problem and just do the players in this case.
How do you manage in terms of efficiency? Because I sort of, like you said, that you're like, you've essentially recreated everything that Roblox does in terms of like the humanoid and the like all the physics simulation. Is that like, I would imagine it would be way more expensive to do that in Lua, whereas like Roblox has like direct access through the backend and they can simulate things with like in C++. Are you at a disadvantage there?
Yes and no. So we weren't sure when we started out with this how far and if it was even possible and how fast it was going to be. Because the big challenge to all of this, to give background context, is this step here where we have to basically wind the world forwards is not possible to do with a humanoid. So you basically have to rewrite a player controller from scratch using nothing but stuff that you can run multiple times in a single frame. And it's very, very difficult to write a solid feeling player controller doing that with what Roblox provides you, because the only way you can stop from falling through the world or the floor is by being a physics object, or using sweeps, or using a whole bunch of raycasts. So we built the first version of this using raycasts, and it was so slow that it was basically borderline, we're not sure if we could ship it. And then I went and recreated an entire collision detection module that recreates all of Roblox's collision from scratch using convex hulls and Minkowski sums. And it turned out to be really fast. In fact, it turned out that 100 players running around inside of ChickyNoid is faster than Roblox's version of it. It ends up using less CPU time than 100 humanoid bots running around, which was astonishing because I'm doing a lot less than this whole thing is doing a lot less than Roblox does per character, because these are not physics objects and these are not made up of dozens of physics objects each. These are just a single box. So you can see I have 100 bots running around this field. Frame rate stable, the server snapshot stable. It's going to lag really badly when I shoot because it spawns all of the debug information. Oh no, I have that turned off actually. But yeah, you can see, and you can see the network usage for 100 players running around is only 24 kilobytes per second with the compression going on. So because ChickyNoid does less than Humanoid does, it's not trying to send over a full character rig. It's only sending down a box and some animation state. It's more efficient, runs faster, and uses less bandwidth.
So is it just like the character that you've like turned the physics off and are doing manually, or is it like if you were to have an object in the world that you're supposed to be able to kick around, do you like that's all like regular Roblox physics on those objects?
Yeah, if you have a prop, like let's say a table and chairs, and you wanted to kick them around, you're not going to collide with them at first, like unless you do extra work, because there's no physical representation of this character on the server, which would own all of the physics props. So if I go to the server view right now.
Wait, so does that mean that like Roblox can take care of like regular objects hitting each other, but when it comes to you interacting with like regular objects, that's where you need to do the collision detection?
With you interacting with regular objects, no, I'm sorry. Can you say again, please? I got lost on that one.
Okay, so there's your character and there's some table and chairs. If the table and chairs hit each other, you're not doing any of the physics for that. That's
no.
But if you hit one of the table and chairs, like that's up to you to tell the server what should happen to them.
Well, to an extent. This is something that I worked on a little bit because there was a project that was interested in using this for pushing tables and chairs around. So if I grab this object and
wait, actually tables and chairs?
Yeah, sure. Let's crates. Let's just go with crates.
Yeah.
Okay, so let's make a crate. Make sure it's not anchored. Make it roughly wood. Okay. Make it a bit smaller. And make a friend. Okay, so let's pop this in. So for one thing, just having a single normal physics prop owned on the server. They didn't simulate. Did I forget to de-anchor them or something? What? I have no idea why that's not falling down. You know what? This is a little bit off topic, but Essentially, if there's no server-owned part representing the player, then you can't interact with any server-owned physics. But there is options inside of ChickyNoid to enable a server-owned part that can push things around. There's just some latency on it, so that's already been done and that works.
Okay, thank you.
The reason why ChickyNoid is more efficient bandwidth-wise than the server is mostly because of delta compression. So the concept of delta compression is really, really easy. Essentially, on the server, we are sending down okay, so what the server is doing every frame is worth having a look through here in this server thing. Probably really interesting for a bunch of people. Spawns everybody in, updates dynamic parts if they're required in the collision module, so like crates that are being pushed around. We pump the commands, so all of the commands that have come down for all of the players, we process them off one at a time. So if you've got a bunch of commands that have come down, and we have a stream of commands coming in from every single player. So if you're running at 500 frames per second on the client, there's 500 frames of your data coming in to the server that it has to step through and wind your character forwards by each frame, one simulation step at a time. And then after that's all done, there's a post thing that's done. The weapons module gets its work. And then once we hit here, we've essentially processed the whole world for a given frame on the server. So we've processed all of the pending player commands, done all the bullets, done all the work on the mods, and then now we start building up a snapshot to send to the players. So the first thing that happens is that last command that we sent down. So if we have a ChickyNoid, we tell the player what the last command was. We tell them about if there was any network errors or errors in their prediction on the server. We send that all down. And we send down the state that we currently are for that player. So this goes out to each player. And then we start building out what's called a snapshot. Now, snapshot's terminology that's come from Quake 3. It's essentially a view of the world's players that goes out every 20 hertz. So I'm using bit buffer in this case here. So we're essentially making sure we don't send ourselves. And then we essentially go through and we know the previous record that we sent them. And we know the current record that we send them, and we take a difference between the two because we're on TCP. We don't have to do a whole lot of work here, and we just send down what's changed. So essentially, every time there's every time a record inside of the character data has changed, we just update that one field. We put a bit in saying that field's changed, and then we send down the contents of that field. And so if people aren't moving around, they don't use any data. And if they are moving around a lot, just the fields that they're changing get updated. So that's really where the big network savings for ChickyNoid come from. Because if I was sending it uncompressed and not using delta compression, it'd be much, much heavier than Roblox's per character. But because we're using this, it ends up being lighter. And it ends up using less CPU too.
Just to pass on a question from the chat, Tyrage77 asks, does ChickyNoid currently have support for server-controlled moving platforms? Does that just work with the current model, or would it require some extra work? Would love to use this in future for our pirate game.
Moving platforms can be amazing or can be the worst thing ever. So I did some work to make moving platforms work with ChickyNoid. Essentially, what you need to make sure is happening is the client is able to, if you want it to be really good, you need to be able to make sure that the client can predict in the future where the platform is going to be. So the server has sent you down a state of where you were in the past, and now you know where a platform was in the past. Like everything we're seeing here of all these other players happened in the past, right? So the same thing for moving platforms. So any platform you get, the server-owned position is in the past. We need to be able to wind it forwards to our current time to collide against it right now on the frame that we're currently rendering. So if you can do that, like you have a parametric thing, like a moving platform is a sine wave or it's moving along a trajectory, then you can make it perfect and you won't mispredict at all. Mispredicts are shown in the net graph by these little green ticks down the bottom. So if you're doing something that the client server doesn't agree on, the server's correcting you. So for some reason, I'm mispredicting against these crates right now while I'm standing on top of it. And you can see that my movement's a little bit sluggish, a little bit blurred, like I'm kind of jittering a little bit. You can see that's because the server and the client are not quite agreeing on what happened on any given frame here. Not sure why. I think because I might actually be getting network ownership of this crate locally. And I have a physics box attached to my player, and it's not quite lining up properly. Yeah, so it's probably just something like that. But as you can see, mispredicts aren't the end of the world. If you have a moving platform on the server right now, like literally just a bobber, and you don't do anything at all to predict it on the client, you just mispredict the whole time you're standing on it. That's not the end of the world. It's just gonna feel a little bit weird and tuggy on the player while it's happening. And the closer you get it so that the client and server directly agree about where the thing is, the less that you'll even be able to tell that the mispredict is doing anything. Does that answer your question? Yeah, great. We can talk about it more offline. We're almost at the end of the time here today. So the last thing that I wanted to cover, I'm going to skip over the security checks because I kind of covered it a little bit, is the anti-lag detection stuff. Okay, so what I go do is I go turn the visualizer for that on.
You should feel free to go a bit over the time if you wish. I think everybody would be happy for that to happen.
More than happy to.
Yeah.
Talk about this all day. But I talk better if someone talks back to me. So feel free to keep peppering me with questions or unmute.
Well, in that case, there's another question. How helpful would control over the reliability of network transmissions be for ChickyNoid?
Control over the reliability. There is one problem that we have with ChickyNoid right now, which is we've had trouble with going into what's called a death spiral. Because this is TCP/IP and remote events, essentially the server can keep sending down network traffic to the client that the client is not able to respond to because of reasons. The loading's super nice. Anyway, and what happens is you just end up getting further and further behind, and and the latency from the server just climbs and climbs and climbs, and the network connection can't recover. That's something that can only happen in TCP because every bit of data that you've ever sent has to be reliably sent down, and so you can end up in a state where it gets further and further behind forever. We detect that inside of ChickyNoid, and once things have basically gotten into a terrible state, the server stops sending you new information until the client acknowledges the fact that things are back to normal, and then it resumes. This basically happens to every single person when they initially connect because things are loading and you're lagging out. But if the server lags out or the client lags out or your network connection drops out, it'll happen again. Or if you hit the debugger. So in direct answer to how much better would it be if we could send this over, I think you're implying if we could send it unreliably or over UDP, what would happen is your effective ping would go down because this is the effective ping time, like basically the plus 50 milliseconds plus buffering plus frame time. Even locally, you've got like 80 milliseconds between when you're pressing an input and the server can confirm it and has sent it back to you because of all of the different queues and stuff that go on. A lot of games are not honest about what your effective ping is. Like if you it's saying it's 68 milliseconds locally, which is basically 50 milliseconds plus 16 milliseconds for a frame. But it's more like It's more like 70 or 80 in this case, because there's actually 2 frames involved, the server frame, client frame. Would UDP make this better? It would make cases where you drop a frame where you drop a packet in the wild harder to handle, but faster. Like if the networking model can completely survive a dropped packet, like it doesn't care and it doesn't have to resend that information, then you would be faster in that particular state. But otherwise, TCP and UDP on modern networks and modern routers is basically the same speed, because TCP sends down a stream of packets without waiting for acknowledgement nowadays, which is exactly the same thing that UDP is doing. It's just what happens when things go badly. Like if you get a dropped or out of ordered packet and TCP has to resend stuff, then that's when your ping will climb up a little bit. Does that answer your question? Feel free to unmute, by the way. I'm happy to talk to everybody. All right. So what I was going to talk about just quickly and lastly, because we're at the end of time here, is the concept of server-side bullet checks. Wow, I'm really floating above the train here, aren't I? Had to write my own terrain collision detection, so it's not quite perfect because I had to cut some corners to make it go fast. So server-side bullet checks, essentially what we're doing is, because we're rendering a view of the server, so the server's telling us where these players were, and we know an exact timestamp of when these objects were rendered on the client. If we shoot a bullet, we say, hey, on this frame of yours, I shot a bullet from here to there in the world. The server can say, okay, you were here at that time, everybody else was there at that time, and I can do that bullet check myself, exactly how things were for you at that point in time. So that's what this module here is called, the anti-lag module. That's that whole concept in a nutshell. So essentially what we're doing is every single time the server updates and sends a new player position down to everybody, I call a routine called write player positions. So we run through everybody, we grab their position, where they were, right out of their simulation. This is the same thing that we were sending down and replicating to everybody at this given point in time at the server time. And then we just drop off super old ones. So after a second, we just throw them out. And then if we want to do a raycast on the server, we can move all of the player positions to where they were at a given time. So this is the player record, so this is the person we don't want to move because we know where they are at the moment, because your position on the server is authoritative. So if you say, at this given time, I shoot, it's like, well, wherever you are on the server at the moment, that's where you're shooting from. And here's the server time that you want to move all of the other players to. It's like, I shot at this predicted server time. If we do some security checks on this, then essentially we grab every single player and then we temporarily, we stick everybody in the world to an interpolated time between the last 2 snapshots that we sent, because that's the same way that you render. And then we leave this function, and then you can do your collision detection check, and then you can call pop to push it all back. So it ends up looking something like this. So to do a bullet query, we grab all the player positions. So the server, the origin, the direction, server time, some debug text. So we push everybody to a given time to check it against the bullets, do a normal raycast on the server, and then we put it back. So every single time you fire a bullet, this is how you do it, so that the server is just getting a command to fire a bullet from this person at this time in this direction, and then making it line up so that you can just aim directly at the player and shoot at them. So the debug visualizer that we're looking at here, this is the way to make sure that all of that is going correctly. So the numbers above here are the green numbers and the green boxes are created locally. So immediately when you shoot, a green box appears, and then once the server is going and updating and moving everybody back to where they were at that point in time, they send you down a blue box. So if everything is lining up correctly, the green box will appear and then the blue box will appear on the server at the point where it thought it was for that time. And if everything's right, it will overlap completely correctly. So if I break it on purpose, can't remember. So we'll push it back by 100 milliseconds. Make sure I delete this and don't commit that code. So if you see if I got it wrong, so you can see that bullet number 29, here's where the player was exactly when bullet 29 was fired, and here's where bullet 30 was on this other green box. And you can see that the server said bullet 29 and bullet 30, I'm doing the collision detection for these bullets where these blue boxes are. So it looks really straightforward when it's all working, but it's actually pretty precise record keeping and interpolation going on to make sure that you get exactly what you saw recreated on the server to do your bullet checks against. This is exactly the same thing that Call of Duty and all of that have been doing for the last 20 years, where you basically rewind the player times to make your collision detection work nicely. I just thought I'd cover that one super quick because you can actually do this without ChickyNoid. You can do this with normal humanoids on the server or anything like that. You don't have to do anything special to record where players were at a given time and then reset them to that point super quickly on the server to do your collision checks with. Nothing ChickyNoidy about that. That's just a really easy technique you can do. All right, so the last thing was we had a couple of bonus topics. Was there... I can't even remember what they were at this point. Was there anything anybody else wanted to cover today, or should we wrap it up here? We can take this to general chat if there's any other questions, I guess.
Yeah, any questions? Well, remind me what the bonus topics were again? You had those on your slides, right?
Yeah, 1 second, I'll just pop that up.
Because I remember thinking I wanted to hear about one of them. Oh, I think it was replication and compression. You did mention it briefly, but...
Yeah. 1 second, I'll just pop it up.
Brooke says in the chat, I'd really like to hear about the security stuff if it's not a problem.
Oh, okay. Yeah. Okay, we'll do security because I did promise to do that. It was on the original topic list. These are the bonus topics. We'll come back to it. Okay, so on security, let me go back to MS Paint Land. On security, essentially, the server is seeing a chain of commands from you forever, from each player, and it is generating a new state every 20 hertz or so when it decides to generate a new state, because it's like every 20 hertz tick long time. It takes all of the commands that it's received from you since then. Still trying to go heads on these arrows, so it'll be a lot better. All of these commands go into this new state. Then all of the next commands that come down, they all go into the next state that goes out. So client generates a whole bunch of commands, generates a new state, client generates a whole bunch of commands, new state on the server. These new states on the server happen no matter what. If you didn't send any commands, no commands, the client can't move that. The server can't move the simulation forwards. So this is what happens in Roblox, or the equivalent of what happens in Roblox, when you freeze the client and it stops sending commands. Like, where command? It can't do anything. So that's part of the security checks that get done on what we call the command stream. So if you think of the commands as a statistical graph, you essentially can see it quite clearly in the net graph here. I wish I could zoom in on this a little bit for you, but every one of these frames here on the server coming by, like on the client at 60 frames per second, these are a command. So these are ticking by at 60 hertz because we're running at 60 hertz at the moment. And then this much slower graph is the server snapshots coming in. Every one of these white lines, white dots, is a snapshot of the world that's come in. These come in every 50 milliseconds. And the yellow line is the average of them. You can see that the timing of these coming in on the clients is kind of gross. Like it's actually, even on the local client, there's a lot of flux in this. This is mostly because as a, well, one, because I'm streaming, it's probably definitely not making this better. But two, because the internal timings of the engine for Roblox are not very precise. So you can see there's a lot of flux even just trying to keep me on a stable 60 frames per second, where it's not. I've done dev forum posts about this and stuff, but essentially the Roblox internal timing is not super smooth. So security-wise, we essentially have a stream of these commands constantly coming in. If I change my frame rate unlocker. Second. My frame rate unlocker no work. No, new version of the client frame. My frames per second unlock is not working. But if I was to jump up to 120 frames per second, it'd be sending 120 commands to the server per second. That was odd. Now, in terms of security, what that looks like on the server side is we essentially have a expectation of that stream of commands coming from the client to look a certain way. So we know that they should be coming roughly evenly spaced. They should be coming with not too much flux in between them. They should be coming with contents that are not corrupted or have random things in them. This is just that list of commands that's coming from the server. So all of the security that we do is basically doing some kind of model analysis on that stream of commands that are coming in and making sure it's sensible. And if it's not sensible, then we react to that in some way. And how we react to that is different and with different tolerances, because we want to make sure that people on mobile can still play, right? So, for example, the most obvious thing that we can do, without showing any code, just super quickly, because each frame that happens on the client, we attach a delta time to it to say how much time it took to render the frame on the client. And because we have to be deterministic and the server has to wind you forwards by the exact same amount of time, it would be possible to speed cheat, right? We can just say on the client, instead of 1 second having elapsed for every 60 frames that goes past, and each frame being 16 milliseconds, we can say, you know what? 33 milliseconds elapsed, and you could buzz around at the speed of light, and the server would be okay with that because it's basically not doing any sanity checking on things and saying, all right, yeah, so every frame that you process 33 milliseconds past, I'll jump your client forward 33 milliseconds for every frame that you come in. and yeah, you can speed around the place. So I'll turn off the security check for that, and I'll show you what that looks like, and then I'll turn it back on. Okay, so there's a speed cheat threshold. Okay. So essentially we're saying if the player's elapsed time versus the total elapsed time on the server is out of whack, then we put the player into an error state saying they're speed cheating. Otherwise, we're good with things. So what we'll do is we'll just kill this out completely. And there's actually a command built into ChickyNoid to try and speed cheat, just to make sure that this all stays working and is relevant. So if this works, I should be able to hold down the P key and speed cheat around. Yeah. So you can see I think I'm getting caught by another cheat, but you can see I can buzz myself forwards here. Now, actually, I think I'm actually tripping out another. Oh, I'm definitely mispredicting with that. So it's not as good as I would have hoped it to be, but essentially, I think another one of my security checks is actually catching this besides this one for the sake of demonstration. But I'll turn it all back on and I'll show you what it looks like if you try and speed cheat with all of the security turned on. So essentially the server's monitoring that command stream. I try and speed cheat forwards, and you can see I'm getting those big yellow security bars in the graph, which is you get one of those bars every time the server says, hey, on this frame, I don't agree with you about the state of the commands that are coming in. I'm going to react to that by either deleting your command or ignoring your command or synthesizing a new command. But essentially what you sent isn't what I processed. And so that causes a mispredict, which you can see, which is these green markers down the bottom. And then when you come back good, you're fine. So me trying to fast forward, trying to zoom into the sunset here, you can see I get a little bit of it because it's a little bit of a tolerance, but other people won't even see that. It's like the server's like, no, everything you're doing is junk, and I'll only process this off roughly how it should be. So there's 4 or 5 security checks that we do on the command stream coming in. Okay, so the checks that we do are as follows. Wow, why is that being so gross? I don't know why Studio's doing these pop-ups over everything that I'm mousing over. Okay, so we have a speed cheat threshold, which is basically saying you have 150 milliseconds of being ahead of where the server says time has elapsed before it'll start ignoring your commands until time catches up. You have anti-warp threshold, which is like speed cheat in reverse. This basically means if you stop sending commands to the server because there's a connection interruption and it needs to be able to process a command so that you keep moving as far as other players are concerned, it'll start synthesizing commands after 150 milliseconds. There's also a buffered command time. So commands on the server are buffered for 20 milliseconds before it starts processing them, just so that you have 20 milliseconds of grace time in case of just mild network flux, so just a little over a frame. So this is just a grace thing, so that you're not hitting security checks just because things are plus minus 1 frame. And there's another check that we do as well. Yeah, so if your total elapsed time has fallen behind, this is the anti-warp check. And so we know how much time we need to cover to catch you up, and we generate fake commands in steps of 1 divided by 60 until you're caught up to a relatively good time. So if you freeze your client in the air, you will fall. even if you stop sending commands after 150 milliseconds. It's like, you need to send us something. You didn't send us anything, so we'll start generating fake commands and pushing them into the queue. And the other security, the other thing. So this is all documented here. And the last thing that I didn't cover is if you send us too many commands because you're running uncapped frame rates, and you're one player running uncapped at 500 frames per second isn't that big a deal, but the server has to do 500 ChickyNoid collision detection steps per second, if that's the case. If you had 100 players doing that, that would be not ideal, right? So it's like the server having to do 5,000 collision detection checks per second because everybody's running at 500 frames per second. No, 50,000. 50,000. Yeah, math hard. So we don't allow that. So essentially, there's a max amount of commands allowed per server frame. So if the server is running at 60 hertz, which it does, it essentially says, no, you can't send us any more commands than that, and it'll make an error state and it'll discard all of the buffered commands if that happens. So those are the security checks that we currently do.
Awesome, thanks. Are there any other questions?
It's clear that this is like targeted at like first-person shooter style games. I wonder how much of a hassle it would be just to like if you were making a game that didn't like super rely on like the needing the anti-cheat and all of this stuff. Like if you just wanted to take advantage of, say, like you made it like more efficient in terms of the networking. I don't know how hard would it be to like drag and drop into like a regular Roblox game.
Okay, so when I originally designed this, it wasn't easy to use this for a new project. You'd basically have to take all of the code and fork it and hook into all sorts of gnarly little endpoints to be able to make changes to it. But I've refined that a lot, especially in the last couple of weeks. I've added a huge modding system on top of this. And so it's actually pretty easy now to hook in and just handle life cycle events on things, and you don't have to care about any of this stuff going on in the background. You can just come in and mess with things on a very at a very high level without having to bend yourself over backwards. So there's an examples folder on both the client and server, and inside there's 4 mod folders. These mod folders are server mods, weapons, client mods, and characters. So for server mods, for example, if you wanted to do a kill brick, this is what a kill bricks mod looks like with this thing. So you have a setup, which doesn't even get used here. And then per step, you basically run through the player records, which is the connection record on the server. And we find the last part that we stood on, we check the attribute to see if we kill, and then we go to the hit points mod, because hit points are done as a mod with this game. There's no basic implicit hit points. We call set player hit points to 0. That's it. That's how you do a brick that murders you in this game. Okay, so that's not really seeing how you mess with the characters, though, right? This is just like game logic looks like this. But things that mess with the character look like this. So essentially, I made a mod here. So any of these mods gets loaded by the server, just runs through them in order and attaches them. If they're inside of the server mods folder, you can say where this folder is. It's part of the startup code. So this one here is called Use Nicer Humanoid. So at the moment, we're actually using a modded character called Nicer Humanoid. If I comment that line out, because per character I'm saying use this character mod, and that's the name of it, I'll show you how this works in just a second. If I comment that out, we don't have the okay, it takes a while to load in. This is a rep. So the default humanoid, the default character that you get with ChickyNoid is a pretty close recreation of the real humanoid. So that same jump height, the same kind of super fast acceleration that you have, the same turn speeds and stuff. So there's a pretty good recreation of humanoid built into this thing, like with the default values. But we're not using that because we wanted to do like variable height jumping, and we wanted to have slightly more weighty player acceleration curves, which are all really easy to set up. So the example character that we actually do run is called Nicer Humanoid. So Nicer Humanoid is this here. So when that gets set up, it just basically goes through and grabs the simulation constants and sets them to a bunch of different values. So if we want to basically got to go fast, and we want to use slower acceleration to get there, and we want to make it so braking is much worse, we can just change the constants on this character that we've set up. You can also set this up for monsters and NPCs or anything like that. Anytime you spawn in a ChickyNoid, like you'd set up monsters like a bot. So now this dude got to go fast. Yeah. Imagine I'm playing running in the 90s here or something. So you can see he's got modifying and making a completely custom character is real easy to do.
Billy spent about 10 hours a day for the last month playing a game that looks a lot like this.
Oh, you're talking about Sonic. It wasn't 10 hours a day.
Yeah, the collision detection in this is all swept, so you can't go too fast. You can't miss with the with the physics steps or anything. You can't end up stuck inside a train or a wall. You can just plow into things because it's all swept collision.
What do you mean by swept collision?
Okay, so when the player moves around, time for MS Paint. Okay, so we have a player, and then we want to update him on a given frame so that he's over here. What we do is we do a collision detection check called a sweep, which is where we start here and we end up here. And instead of like just discretely seeing if there's a wall there, right? And if we move so far that we ended up on the other side of the wall and we tunnel, if we were just checking to see if we were touching and then we're touching, you'd fly through. But we do a sweep. So what that means is we actually project this box along the velocity line and then find out where we actually ended up. Thank you for everyone coming today. If you need to take off, that's fine. I'm not offended. Been talking for a while. So that's what happens. So we go projected forwards. This is where we ended up. So that's a sweep. So
I'm trying to like a gnarly edge case that makes this hard to like determine. Like, what are the like? Are you relying on like convexity of something or like simplistic shapes or?
Yes, and yes. Okay, so the magic behind all of ChickyNoid and the reason why it runs reasonably fast is another one of John Carmack's inventions, because he's this patron saint of video game code as far as I'm concerned. Where if you have a box and you need to sweep it through the world, God, it's terrible at have a box, you need to sweep it through the world. You basically need to make a new, if you were doing it GTK style, you'd essentially make a convex prism of all of that and then see if there's any collision points between that and the world, and then move it so that it's not, you'd find the time of separation yada, yada, yada. That's a really difficult problem, and probably too difficult to do at real time inside of Lua, because essentially you're doing a convex hull check against all of the other convex hulls in the world many, many, many times per second. So what we actually do in ChickyNoid is we have exactly one player hitbox size that we support. We know how big the player is. And then when we build the world, we do a Minkowski sum on everything. So let's say you have a part that looks like this. And the player hitbox looks like this. And you basically want to be able to check to see if these two things are colliding. What you can do is you can expand every single one of these parts by the same size as this box. So if we subtract the size of the box from this part, reducing it to a single point, and we expand this box by essentially adding this box onto every vertex of this thing and then taking a new convex hull, we essentially reduce the problem down to a point versus an expanded convex hull. And if we need to move, it reduces to an array versus a convex hull. So that's the magic math behind ChickyNoid and why the collision detection runs even at all in LuaU, because we're not doing swept convex hulls versus the world, we're doing rays versus the world.
That's very cool.
Yeah.
There was another question in the chat. May have asked you this before, but what is next on your list for ChickyNoid? Would you say it's feasible to use yet in a 100-plus player environment, or are you waiting on anything from Roblox to make it even better? I know you were really wanting box sphere casting, but now that you did your own, I'm imagining that's no longer a requirement.
I mean, I still want that from them, because if you saw what I had to do to make the terrain collision detection work, you'd throw up a little bit. Like if I go to terrain collision, I don't know if this debug command still works. Turn it on, see if we can turn the bots off, just to make sure that the bots don't mess with things. Server startup script. This is what you have to do to make ChickyNoid work, by the way. You just have to tell it where the collision detections are, register your mods for server mods, characters, and weapons, then call setup. So we'll add 0 bots to the world. So do you know how I was talking about everything has to be convex hulls for you to collide against it? For terrain, that means I had to basically analyze the terrain as you move around and generate convex hulls that are fitted. Wow, that's actually doing a really terrible job. It used to, I think I've made a mistake there with some of my code. Recently, I was adjusting it to fit the terrain a bit better. But as you can see, that's the work it's doing internally to generate convex hulls, little boxes that are fitted to the terrain, and then Minkowski expanded so that we can ray trace against them. This is gross. This is literally the worst thing ever, and I hate it. But it's what we have to do until Roblox provides us with their own replacement for these things. So you can imagine 100 players running around, servers having to calculate these for... I had to do a whole bunch of optimizations to make this fast, and I think some of those optimizations don't work properly. Hang on. I definitely screwed something up there. They should not look like that. Oh, and also, if you create a whole bunch of parts and then you stop debugging in the studio, you get this. You get a freeze when you try and close the
So is that like a marching cubes type thing? How are you doing that?
It's very much marching cubes. It's not quite marching cubes because I know I'm building a convex hull, which means essentially it's a box. It's always a box. It's not just trying to find the top surface. Yeah, so that's a bit more well fitted and accurate. Less little glitches. So essentially, if I was to sketch out what's going on here, the 2D case would be if you have 4 points and you need to know if these points are inside or outside of the terrain each. So essentially, we're needing to know, we have 4 spans to check. We start off by checking each 4 corner, right, to see if it's inside or outside. So if we had some terrain that was running through like that, we'd know that, these 2 points are in, these 2 points are out. I'll just leave them purple. And our intersection points are somewhere in between these. So we have a mismatch on this span here, and a mismatch on this span here, where this span is saying 1 is in, 1 is out. And so 1 is in, 1 is out. We know that the value of the SDF field that makes up the terrain, what that value is, and we know this value is 0. So we know the intersection point is roughly here. We know the intersection point is roughly here. So essentially, to make a convex hull from that, we just submit all 4 of these vertices to a convex hull generator, and we end up with this box.
Can you say again how to tell which points are inside the terrain? You use ray casting? Because I found the ray casting to detect terrain a bit unreliable.
I did not use raycasts. What I do is, well, you have all the source code for all of this, by the way, if you ever want to look any of this up. It's all open source. So terrain collision, what it is doing is using the, this is the worst thing ever. I've just given up at this point. I should have used a key for that, but I just couldn't be bothered. What I'm using is no, that's the wrong thing. I'm using the read voxels, terrain read voxels. So I read the voxels to get the occupancy of the terrain, and then to read the 4 corners. That's basically if any of the 4 corners of this thing, the top 4 points or the bottom 4 points, are inside the terrain, they emit a vertex to my convex hull. Then I check the vertical spans, which is essentially these guys. Then I check the horizontal spans, and then I check these ones. So you're starting to get the idea that I end up basically, for each span that's possibly intersecting the terrain, I emit a vertice, and I can tell it's intersecting because one of the points is in the air and one of the points is not in the air. Now, how I tell if a point is in the air or not, which I think is the direct answer to your question, is span check. Oh, I've already calculated it. Wait, so yeah, so I'm doing a sample, right? So I have a thing to sample the occlusion at all of the 4, sample the SDF field at all 8 corners of the box. And what sample is doing is it is basically doing a read on the average of 8 samples of the SDF field, because we're sampling the corner, not the middle, which, again, worst thing ever. And then we can tell with the SDF field, the SDF field for Roblox isn't positive and negative. It's not actually a sign distance field. They actually bias it by, I think, about 2.25 or 2.0 maybe. So what that looks like is, instead of like a blob of terrain, everything inside of here being a negative distance from this surface, and everything outside of the terrain being a positive distance from this surface. This is what's inside the terrain occupancy field. What they actually have is the occupancy once you sample it out of their grid, is where the crossover point between the air and 0.25 solid is where the surface is rendered, and this is 1 here. So it's basically the same as an SDF field, except that the math is a bit wonky because Roblox. So. Well, this was fun. Nearly 2 hours now.
Yeah, thanks very much. I guess we can
no problem.
leave it there.
Good fun.
That was
I
terrific.
actually didn't even know that's how occupancy worked. Yeah, I learned.
Yeah. Occupancy is an SDF field. That's why it's not stuck on a grid. And some of the meshes basically say if there's any occupancy at all in this box, draw a box like the wood type ones. Like it doesn't. But the other ones basically try and find that crossover point where between two vertices, where does it cross over a certain threshold between 0 and 0.25, and then it places the vertex there. And then some of them have a Perlin noise applied to that threshold value, which is why you get like those wobbly terrain types, like rock and stuff like that, where they're a bit crinkly. It's just because they're just messing around with where the intersection point is. Yep, I'm going to jump off and we can pick this up on general chat. Thanks very much, everyone. This was a
Hey,
hoot.
Mr. Chicken Robot.
Yeah, thanks a lot, Peter.
Yeah, thank you.
Thanks.
Okay, goodbye, everyone.